Thanks for waiting, everyone. So, Mohammed, I'm going to hand over to you. Please take it away.
Okay, good morning, everyone, and welcome to our second CISA YPF KZN event of 2023. Our presenter today is Shuaib Yunus, who is a senior BIM technical specialist from Baker Baines. Shuaib has been involved in numerous projects involving BIM and will be taking us through the topic BIM for smart infrastructure civil engineering. Please can any questions be shared in the chat, and Shuaib will answer a few of them at the end. Thanks. Over to you, Shuaib.
Thank you, Mohammed, and good morning, everyone. Let me just switch my camera on. Great. Thanks, everyone, for joining us today. And today we're going to be talking about BIM for smart infrastructure, specifically on civil engineering, although infrastructure kind of transcends all of our consulting expertise. But I'm going to be taking you through how possible and how imperative BIM can be in our space. So you've just a little bit about me. I am Shuaib Yunus. I am the Senior BIM Technical Specialist for Civil Infrastructure and Mining here at Baker Baines in South Africa. That's just a little bit about me on the screen. In terms of the work that I do and the projects that I'm involved in, at Baker Baines, I'm involved in numerous projects involving BIM for civil infrastructure, GIS, common data environments, geographical information systems, reality capture, scan to BRIM, so the use of UAVs and stuff like that, as well as virtual reality and visualization. And of course, if you would like to reach out to me directly, that's my email, shuaib@bakerbaines.com. So just a little bit about the company that I work for. I work for Baker Baines. So just to give you an overview of what we do, we are a consulting company primarily focused on digital transformation throughout the variety of different disciplines in our world, basically. If you want to confine those will be building, architecture, civil, engineering, process plant, energy, mining. So we play a lot in the variety of different sectors that actually form the infrastructure that we need here today. Of course, we also back a really cool and really positive, hard-hitting technologies that help us as engineers to design and make a better world more intelligently, more sustainably, more economically. So this is just a quick one slide of who we are, what we do. Of course, if you want to find out a bit more about us, you can always reach out to me directly. All right, so for our agenda for today, we always start off with an industry context, especially from a South African perspective. So we're going to be looking at the infrastructure industry and how it is developing here in South Africa. And then, of course, we're going to dive directly into the meat of the topic, that being BIM for smart infrastructure. And then, of course, we will close it off and also tell you how we could actually help you. I would get to some of the questions at the end of the webinar, so you don't have to wait till the end. You can always fire them away into the chat box, and I will get to them at the end. So let's look at the industry context specifically from a South African perspective in the civil engineering or infrastructure industry. Now, if we had to simplify this, we would have to say that there are different components of infrastructure. The components being horizontal. So if you're looking at roads, rails, bridges, tunnels, linear or utilities, as well as civils, so your pipe networks, those type of things, we characterize them as horizontal construction. So anything going probably that way, it is horizontal, right? And you can see these are very critical components already from an infrastructure perspective. Now, we've also got the vertical portion of that being the components of vertical construction. So your typical skyscrapers, your telecom towers, housing, retail estates, industrial parks. steel structures, sporting and recreational, as well as medical, commercial, etc. So we've got infrastructure encompasses a wide variety of different components. And it's very important to understand these components because they integrate and also operate in different manners. Now, I'm not sure if any of you have had a read of this report. It was the SAICI Infrastructure Report Card for 2022. And basically, it had certain grading definitions based on the infrastructure that we have here in South Africa. And this was the grading system that was used. It serves as like an informatory type of document, so you can read it. It's widely available. I've actually got a quick snippet of it that I will show you in a bit. But you can see the grading definition that is available. So A being world class, B being fit for future, and of course, going right down to E. And of course, these short descriptions of how or what these categories comprise of. Now, if you haven't seen this report card, here's a quick snapshot of it, right? So you can go to the report, you can have a scroll yourself. This is where I got the actual gradings, and you can see it characterized per segment. So water, sanitation, solid waste, roads, and so on. So it looks at, it's quite a very good report. You can go have a look at it, and it gives you an overview of what things are impacting the infrastructure here in South Africa. Of course, there's an agglomerate of different factors. And of course, this report digs into them a bit, also on a provincial level and so on. So if you haven't read it or have a look at about it, or probably didn't hear it, please go check it out. It's a really informative report if you are a consulting engineer, especially here in South Africa, so that it'll give you a good understanding. You can see that the overall grade we got is D. And of course, I think all of us here on the call would like that to be closer to A, right? So this gives you a good snapshot of what's currently happening in South Africa. We actually had a discussion about it last week at the SAICI offices in Midrand. And I think all of the engineers collectively shared these same concerns. Now, population or demographics, dynamics, all of that impacts what we need as a nation, as infrastructure requirements, service delivery, and so on. And based on the data of Stats SA, in, I think it was July 2022, yes, there's just about over 60 million people in South Africa, right? So that's a large number. It's going to be probably past 61 by now. I'm not sure, but this is the stats that we get. Now, generally, as a technical specialist, we look at the stats because that also, the concept of supply and demand, it has a great impact on our infrastructure, service delivery, how we would take things, how we can plan. And all of this pressure, it fosters us to think of better ways to provide infrastructure, right? As a consultant, irrespective whether you're in infrastructure, you're mechanical, whatever it may be, you need to look at smarter ways, innovative ways, sustainable ways, economical ways to provide infrastructure. And of course, it's primarily driven by population, demand, and supply. Now, just to give you some other stats, this is on a global front. This is a report done by Autodesk and Statista, where they took stats from different regions or different portions around the world. And if we zoom into Africa, you will see that these are daily averages on a global level. I'm going to repeat that. It's daily. It's not monthly. It's not yearly. It's every day. So if you look at Africa from a road perspective, we need to construct about 394 kilometers a day, right? Again, primarily focused or governed by population, infrastructure demand, and so on. Because of the rate of urbanization, we're going to need to look at smarter ways, more resilient ways, more intelligent ways to actually do things. So we've got Africa at 394 in terms of roads, kilometers per day. In terms of buildings, we're looking at about 968. And of course, if you look at our urban growth as Africa, projected to the year of 2050, we will have the largest urban population projection, 3.1%, right? You can see the rest of the world is currently looking at 1.3%, and the closest being India at 1.9%. So Africa has a lot to develop, a lot to look forward to, and also a lot of opportunity. So this gives you a global context. We've got a local context, we've got a global context, and you can see that infrastructure demand is a really, really concerning and imminent thing that we need to solve, right? Of course, you can also see rail is at 153 kilometers, power grids over 17,000, and water and sewer over 32,000. So those are all staggering numbers. And again, the fact that it is an average daily account or data, that is also quite concerning in terms of how will we keep up to actually this growing or urban population, the demand and the supply. Now, the reason why, based on our experience and the projects that we've been involved over the years, we attribute it to the actual old way of thinking. Now, again, there's a lot of factors that contribute to infrastructure, the lack of providing it much more on time, on budget, economically, sustainably, and so on. But one of the key ones is actually digital transformation. Now, in our sector, the digital transformation, unfortunately, is lacking. It is growing now over the years with the awareness of different methodologies, technologies, and so on. But still, majoritarily, I mean, you're looking at the old way of thinking. Now, what do we call the old way of thinking, or what does it look like? So, of course, before going onto the digital sphere of things or onto a digital platform, we did things on the drawing board, right? Technical drawing. The first jump was, of course, using AutoCAD. So that was the first wave of digital transformation, where we migrated from the drawing board onto a computer screen. And that was, of course, AutoCAD. Unfortunately, people are still using this elementary technology. Of course, it is purpose-built depending on the application that you're using for. But however, if you are looking at metadata, informed asset management, maintenance, and so on, it's not really suitable. And the reason why we say that is generally you would PDF destroy, right? I think we all kind of PDF it. We don't give a 3D model with metadata or asset data attached to it. That is normally shared via email. And the problem with this is the loss of intelligence and crucial information that you would need, especially at the handover stage of the project. So if the custodian is the government or municipality or wherever it may be, it's just lines. Whereas if you have a digital model that's data-rich, visually impressive, you could simply click on, for example, a pipe, a column, a road, you get the elevation data and so on. Whereas this methodology, if you click on a line, if it's doesn't have text on it, you don't know what it is. It could be a fiber network, it could be a pipeline, it could be a road center line, it could be whatever it may be. And this is the old way of thinking. And unfortunately, as you can see, the stats that I've just showed you previously, this way of working is not conducive to actual intelligent, effective infrastructure delivery, because you're not going to keep up because it's manual. It's very, very intensive in terms of getting to an end product that is resilient, economical, sustainable. And this is where actually BIM comes in, right? So BIM is a methodology that will get your project started off on the right foot, full of intelligence and innovative flair. So what is BIM? Right, so BIM is the acronym for Building Information Modeling, or Better Information Management, as it is now popularly being attributed to. If you haven't heard about it, that's great. This is the place to be. I mean, we're talking about it. It's an informatory webinar to all of the consulting engineers out there. So Building Information Modeling, or BIM, is an intelligent 3D-based model process. And it can be applied in a variety of different disciplines or industries. So the I would say the positive or the more popular one in terms of uptake and application is the AEC industry, so architecture, engineering, and construction. But we have applied it and utilized it across other industries such as process plant, energy, manufacturing, and so on. That type of workflow or that type of project methodology, we call it a convergence workflow, where you've got, we call it Lego construction, where you would need to partner with manufacturing, prefabrication, and so on to create infrastructure much more intelligently, faster, okay? And of course, economically. So BIM is applied in these different workspaces. Now, why is it so popular? I mean, if you might have heard it all over, either on LinkedIn or whatever social media. If you read a lot of white papers or theses or dissertations that are coming out, they're actually focusing or swaying towards BIM here. And it's an effective way for lifecycle management on a building or infrastructure project. But of course, BIM is just not the technology. Connected BIM is the incorporation of cloud computing and functionality, as well as a common data environment, which we will then touch on in a short while. So speaking about BIM, there's also a misconception that it is just technology. Remember, building information modeling is a process, right? So that process, technology is a part of it. It's not the only thing. And a big part of that is building standards as well as working processes. So again, it's not a software alone or a physical item or object. It is focused on the efficient management of the project lifecycle. At the end, you should get a virtual asset. That could be graphical models, asset data, documentation, or a simple term being information, an information model, which is intelligent, again, streamlining asset management operations, and of course, extensions, right? But the key thing is the actual information. So how would you collate or bring together the information, how you would communicate with different stakeholders in a consortium, in a multidisciplinary environment, how you would manage that information. And this is all done digitally, right? Again, that's why we call it better information management, because if you have all of the info, all of the processes, the methodologies attached to the project, housed under a common data environment, you have all of that information to better run that asset as well as maintain that asset. Now, if you're looking at a technology snapshot, right, so infrastructure model, this is what it could look like. It can get much more comprehensive, but just to give you a simple snapshot, you can see the model at the center. Let's say that's what we're trying to construct, we're trying to design, we're trying to get towards, right? We can integrate a lot of technology or data together to get the output that you see on the right-hand side of the screen. So that could be civil data. It could be for roads, bridges, tunnels, structures, and of course, building projects. Building projects are more of a comprehensive or multidisciplinary nature, where you would also involve consultants in the mechanical, electrical, plumbing, energy systems, and so on, as well as the plant and process environments, so the mining industry. Very critical part of it is also GIS, so geographical information systems or geospatial data that will help us inform our design so that we don't hit that pipe on site when we are constructing or excavating. So with that data, we could link that to our model. So it informs our decision making when designing, for example, something like the infographic in the center. That also informs utilities, so service delivery for water, sewer, bulk water, stormwater. I mean, all of that can be informed to intelligent networks. Of course, survey now, there are so many different ways of getting terrain data. That could be UAVs, fixed scanners or laser scanners, portable backpacks, mobile mapping units. The end of the day, whichever way you choose to apply, that data can be integrated in a live model. So you can generate elevation models, alignments, long sections, cross sections, I mean, quite easily because it's an intelligent environment. Structures, coordinating, especially working on road projects quite a bit, the coordination between the road corridor and the actual bridge itself, the decking, the piers, the offsets, all of that is quite a comprehensive and an integral part of ensuring that the project goes and is constructed at the correct elevations. And then, of course, reality capture, which I've already touched on. So those are just some of the things. Like I said, it can get much more complex and much more cooler in my opinion. But if you take all of that data and you streamline it in an intelligent manner, the outputs are quite amazing. Like, for example, you could link in your model to an automated machine guidance. This is more on the road side or civil sides of things. So, for example, airports are doing this quite a bit, where they would get up to 1 millimeter accuracy using machine guidance and machine control, which is fantastic. You could take your model, upload it onto your plant, and you're good to go. Another thing from a project management perspective, so if you're a project manager in a consulting field, scheduling can become a nightmare, right? Especially when it comes to multidisciplinary type of projects. We have the ability using BIM to go up to 4D, 5D, and some papers saying 7D, but 4 and 5D is pretty much the notable effect of it. So 3D being the actual model, what you're seeing on the screen, the 3D model. Then you've got 4D. 4D is when you attach the element of time to a task. So if you take your MS Projects schedule, or whether you do it in Primavera, Excel, whatever it may be, if you link that to your task on the model itself, I could simply click play and I could say, okay, after 2 months, where would this project be? So I could actually integrate and interrogate the 3D model that I'm going to be constructing. So I could say, okay, column C1, C3, C5 are finished. The footings are done here. The concrete is still being cast for the V-drain. The foundations, this portion or this panel has been cured. The shutters will be on this side. So the more detail you apply it based on your start and finish to start tasks, you can link that to your model and you can actually see what it's doing. And what we've seen on certain projects that we've been involved in, it has helped consultants save time, especially when there's a delay, an unexpected delay, maybe for material or whatever it may be. So you could see which tasks you can run concurrently to save time so that you can meet that deadline, so you don't get penalized and so on. And 5D being the attachment of both time and cost to the actual 3D model. So it's absolutely amazing. You could use it quite nicely, much more insightful. And again, it informs resilient infrastructure because you could consolidate all of the different models from the different disciplines in consulting, and you could run a clash detection where you could see that the pipe is in the wrong place, the column is in the wrong place, maybe the ducting is also not tying up correctly, and you could address that to the relevant consultants. So you have all of that at your disposal before even hitting ground on site, which is absolutely amazing, so that you can reduce that variation orders and certificates that you would normally get, the extension of time and so on. And as you can see, the estimation also is a big part of it. So you're getting accurate quantities. Because it's linked to a 3D methodology, it extracts the quantification directly from the model. Whereas the old way of working is we had the plan view, we had the section views, we had the elevation views, and we relied on taking those 2D views. And when we put them together, hopefully it will give us the 3D correct infrastructure asset that we're building. Whereas here, the 3D model or infrastructure asset is at the heart of the technology process. And the views, elevations, and sections are extracted from this model. So if there's any change in elevation or thickness of a material or whatever it may be, shift of an alignment, it updates in the corresponding section and elevation views. Whereas the manual or old way of thinking, we would normally miss something. I've had this experience on site where we either reduced the depth or the height of the retaining wall, and you forgot to update the section. So the steel goes off, the setting goes off, and so on. So you can see the intelligence already coming in. So the documentation estimation is directly linked to the 3D model. Visualization is an amazing byproduct of this process. So you can assign material, textures, rendering qualities. You can do fly-throughs, virtual reality, walkthroughs on site, and so on. So this is just a quick snapshot of the BIM technology is a part of the BIM methodology. Remember, the technology is not BIM, but it forms part of the methodology, the process that you would apply so that you get a well-oiled system for your project cycle. Speaking about that, this is where the common data environment comes in. So a truly BIM process, like in its entirety, cannot be completed without the incorporation of a common data environment, so a CDE. Now it is more on the cloud. We've seen a lot of different processes, also companies, organizations move to the cloud. The acceleration of this, or the catalyst of this, was actually COVID, where we couldn't go onto the construction sites, we couldn't go onto the mining sites. And we had to collaborate in such a manner that we could talk to the construction teams, connect the design office to the construction office, ensure that everything was going on site. So what was designed versus as built was coordinated effectively, and cloud was the solution that was seen to be the successful recipe. Now, an incorporation of a common data environment, it serves as a single source of truth, meaning everything on your project should be housed on this. It could be teams, it could be the permissions of those teams. So if I was the civil engineer on the project, I don't need to see what's happening in the electrical or the mechanical side of things. So if I logged into the project based on my permissions, I will only see, for example, the civil infrastructure designs. And it's not only to the designs. You can have your claim certificates, you can have your construction logs, your daily site logs, your rain days, you can have photos on there, approvals. So if you need something to be approved on site, or if you need to request more information, we call them RFIs, based on something on site, maybe it's not going according to plan. All of that is managed with this CDE. So there's no problem of email file sizes getting lost in your junk, using external OTP sites or whatever it may be, where you can't open the model, you have to download it. This is all accessible, on your mobile. So you could just log onto your browser, log in, as long as you have access to that project. You could open the model on your phone, make notes, markups. So reviewing data as well, it's much more streamlined, where you don't have to print it, write whatever you need, put your revision clouds, scan it, and email it to someone. You can do it directly on your phone, directly on your computer, and it can be assigned to the person that needs to fix it. So you can already see the digital footprint that is coming of this intelligent workflow, right? And of course, it's governed by standards. We've currently got the ISO 19650 standards or series that informs you how to go about on a project, that the product will be efficient project or better information management, as you've seen. So intelligent technologies, intelligent common data environments equals intelligent processes, methodologies, and workflows. And you can see it transcends across the different consultants in our sphere. So if you want to go more on the academic side or on the stat side again, I will show you what the BIM benefits are. I've just summarized them into one slide. So of course you can see it's from a very reputable source, Dodge Data and Analytics. You can also find some from like McGraw and Hill and stuff like that. But these ones stand out quite a bit. So from a business perspective, so if you are a director, you own of a consulting company, these are the 4 main challenges that I have actually seen BIM solve from a business perspective. So first of all, it gives you a competitive edge, right? If you can do work much more faster, efficient, intelligent, and much more economical, so your estimates are better, your economy is better, and so on. Great, that's going to get you more competitive because you get work out faster, you can get more work in faster, and makes you more profitable, right? So competitive advantage and increased profitability go hand in hand. And then, of course, the last 2 also go into that. So reduce business risk and hiring and retention, because now you know what you're doing. Your workflows, your processes are more transparent. And of course, then you're going to be creating specialists in your environment. So you've got that skills per specialization or whatever it may be. So it helps you to retain more people because you're using technology. And I think all of us here are for technology, right? So you're doing things much more smarter, innovative. Those 2 go hand in hand. Then we've got the project benefits. So these are just a few. You can see fewer areas. I think a lot of consultants can actually really take away from this, where we don't pick up things in the construction or on the peak of the project. That's like the worst time to find out that something is wrong, because you can't do much with it. Because you either have to dig into your contingencies, apply for an extension, or you're going to get penalized because of those errors, right? It could be on the construction side due to the design. It could be on the design due to the construction floor, or both. Whatever it may be, you don't want to find those errors late. And you can see you can optimize your design. You can schedule better if you're project manager. You can understand better whether you're the designer, you're the director, you're the draftsperson. You can understand better what you're designing, what's your output, what's your vision. And that, of course, has a greater cost predictability attached to it. The last one I've attached from my experience, from a technical solutions perspective, the benefits from a technical standpoint of BIM. So of course, the common data environment, it works amazingly. So once you've got it structured correctly, you've got your teams added, you know this is your execution plan, this is what you're going to use. It works amazingly. You have a digital trail that works and keeps track of everything on your project on a hub. That fosters better collaboration across multidisciplinary and consortium-based projects. So when you are dealing with different consultants on your project, it makes it much more easier because everyone knows what to do, where to put the data, how to collaborate, the effective manner of doing it, sharing data, and so on. GIS transcends, I think, all of our consulting expertise, because we need the metadata or the historical data or the legacy data that is available in the region that we are developing. We don't have it in every single region, but I think it's constantly being updated, the databases, where you can go and draw from the design and take it from there. And last but not least is, of course, the dynamic live nature of this process, because everything updates instantly. So you're getting the accurate construction drawings available. Your model, the quantities, whatever it may be, it's dynamic live design. It's not a dumb, unintelligent process. Okay. So I've given you a good rundown of what BIM is. I've given you the stats. I've given you the scenario in South Africa. I've given you the global context. But what's happening here in South Africa, right? So I'm going to show you some projects that we've been involved here as Baker Baines in a variety of different sectors, and we call them BIM success stories. So the first one is, of course, a bus rapid transport station or system that was being needed to upgrade in the Sandton area. This I personally headed up as a part of Baker Baines. And you can see this was a very complex project. And why I say that is it had a varying median. It had a varying retaining wall that split the mixed traffic to the actual other components in that area. It was very confined, meaning we didn't have enough, or we were concerned about the space, whether we would be able to fit all that infrastructure in that confined space. Also, the positioning of the station, you can see the high floors and low floors, whether it's going to be coordinated correctly, the setting out data, making sure that the grades were correct, all of those things in a confined area. And of course, being Sandton, the aesthetics is a big part of it, right? So the 2D design of this, as an engineer, I think we all understand our technical drawings, but if you have different people in the consortium, maybe someone's just funding the project, or you might have someone that's not technically as engineering inclined as yourself, you need a visual model. So this project, it formed part of the Rio Via bus system, and you can see all of the data on screen. And basically, it wasn't going ahead because there was ambiguity on the panel, because the engineer was saying, no, the design is fine. There's all the data. People couldn't visualize it. They had concerns of the aesthetics and, of course, the confinement of that area. And by linking or using using the BIM technology component of the BIM process, we managed to get all of that data translated into a visual 3D model that was accurate and engineering compliant. So you could see exactly what your infrastructure was going to look like. I mean, that was the retaining wall at one section. You can see it varies. You had it at a set engineering shape that was parametric. We then modeled it onto like a 3D type of view. We linked it into the model. And of course, we added some immersive realism to it. So we could add in like the shadowing effects, the light posts, the actual architectural stations that were coordinated and geolocated correctly per level. We added some cars, some city furniture, we added some people, and we even did like a fly through of the project. So this helped a lot, and it was a great example of showing that on transportation projects, because they're so complex in nature, being linear and traversing different areas, value properties, and so on, that you can translate it in a visual manner as well, being intelligent and engineering compliant. So that's just one from a transportation perspective. This was a very impressive project also that we did. It was for, the Kangness wind farm. And it was a great example of the BIM convergence workflow, because you have a lot of the mechanical, process, plant, energy, mining sectors here. And of course, the site civils is everywhere, right? So you need to grade the site, the setting out, and so on. And you can see it was responsible for lighting up 155,000 homes. So that's a big responsibility, and you can't use the old way of thinking on this type of project, because you'll end up pulling your hair out. It's not going to be great from a costing, quantification, and so on. And you can see the convergence workflow using intelligent processes to do the infrastructure, linking it with the civil design. There was a lot fewer issues to deal with. And of course, the embracing of a common data environment. So this project, again, very impressive, and we involved, it was in the Northern Cape. This one was also a very innovative project from a building perspective, systems perspective. It was a medical facility for Mediclinic in Cape Town, and it is one of South Africa's few 5-star Green Star SA rated buildings. So it was very sustainable, or reaching that Green Star rating. And I mean, look at this, the design versus the as-built. That is amazing, right? It's quite purpose-built. You know what you're designing. You can coordinate it better. It increased the consultant's workflow anywhere from 15 to 30%. And of course, as you apply it and you keep wielding this process, it just grows incrementally. So again, this was a very cool project, and no problems. Everything was to the T. This project was a very comprehensive project. It was in Seriti New Val de Colliery LifeX feasibility project. It was located in Valfontaine, and it had a lot of different complexities, right? Again, a part of this project a bit, civil, structural, mining, steel, reality capture. I mean, there was a lot of things that you had to integrate. Again, using the BIM, just the technological component. The reason why I'm showing you the technology component, I think more people can absorb that better, right? Some of these incorporated the full scale, being incorporating a common data environment. Some consultants, because they were new at it, they started at the technology space, which we see in South Africa and Africa being the first step that consultants are taking. Start with the technology, right? Yeah, so you can see just some of the models that were designed from this. The project was 176 days long. And of course, there was a 30% gain in productivity. And of course, this company, Junkin and Associates, they are incrementally also gaining it. And there are some projects that they've reached up to 80% in efficiency. So just look at that, transitioning from the old way of thinking, or 2D workflows, to 3D BIM technological workflows. Just the technology component is so impactful, right? Imagine incorporating like the common data environment, having all your data on there, your finance, remember, on the common data environment, you don't only have to have the designers. It can be from project inception right up to handover. So all of your accounts, your accounting, your financial team, your contractors, whatever it may be, all of that data can be housed on a common data environment. So that just gives you a context of what we've been doing here in South Africa as Baker Bains, and you can see the proof is in the pudding. Those are just some of the success stories. If you want to check out more, you can always head out to our website or hit me up. there is a lot of good stuff that's happening in South Africa and on the African continent in general. So just keep your eyes out for those type of things, or if you want to find out, just reach out to us. So from a global context, what is happening with BIM? Like, is it really making waves overseas? What's happening in our African continent? All those type of things. This is a good outlook, and it was published in 2022, so very recent. It shows you the progression of BIM adoption across the world. It's a global outlook. And you can see in Africa, especially South Africa, we are on there. BIM is being recommended. Okay. You can see other global regions, they've got it mandated. Some got open BIM standards already. That's primarily charged by the UK. They're very big in that space. But it is a global thing because all the regions across the world are seeing this as the way to go, the methodology to go, especially if you're a consulting engineer. The technology, like I said, is just the entry part of the BIM ecosystem. There's so much more that it goes into. And of course, it's governed by methodologies, standards, workflows, processes, and so on. So you can see it's not just something I'm telling you for the sake of telling you. It's a global thing. It's a global thing. So it's filtering down to Africa. And I think soon, I can't give you a timeline. This might be mandated. And I think it'll have a good impact on our infrastructure because we'll be creating infrastructure that is intelligent and resilient. So that's just a global outlook on things. This was another report done. This report was a very comprehensive report. It included every single continent beside Antarctica, of course. And this was the question posed. Again, very good report. I just took this snapshot from it. So from your understanding of BIM, how strongly do you agree or disagree with the following statements? So adopting BIM has increased or would increase coordination of construction documentation. You can see 85% agree. And what's more interesting, those that haven't adopted in blue, they agree, but they haven't adopted it yet. So this could be due to resistance to change, but it's a bit of a daunting process. I mean, you've been doing things like this for, like I would say, forever. How would you go about it? I mean, that's why there's people like myself, there's companies like myself, there's professionals like myself that are helping you to do this. They're educating consultants, they're helping consultants, they're working on projects with consultants. And just look at those numbers. I mean, 85, 72, those are all good numbers. And the blue being that people know that it is a winning recipe, but they haven't started on their BIM journey. And of course, there was an African report. So the BIM Africa report, this was done particularly looking at our African continent. Those were the type of disciplines or professions that were interviewed or they got to chat with. And you can see the adoptions based on the standards. You can see the legend at the bottom. So none, we got the BS 1192, we got the PAS, and then of course the current, which superseded those two, 19650. We got NBIM in the US and of course others. So based on that legend, you can see that the adoption that we are having, you can see we've got Central Africa, North Africa, East, Southern, and West. Those are the percentages or the distribution amongst them. And of course, what standards they're currently using. Majority is currently, we don't have a standard. There's no mandation yet. I say yet, but it is swaying towards that where consultants have taken it upon themselves to start working in the new normal or the better way or better information management type of ecosystem. So we've got a good context over Africa, globally, and so on. Okay, so let's close off and then I would take a bit more of the questions. I'll check the chat box, but let me just summarize this. So based on the World Economic Forum, they have 10 disruptive technologies. Disruptors are seen as things that would cause a stir in industry. It could catalyze the industry. It could have a good impact in terms of innovation, acceleration, adoption, economy, sustainability. I mean, one of the things that I've currently into is LBM, so living building materials or advanced building materials as it's called on this chart, where you get like self-healing concrete or you get adaptive material that based on time and function, it gets better, right? So that again, sustainability, maintenance and stuff is pretty good. Now, a part of this top 10 disruptors, building information modeling is on there. So you can see it's quite a big thing, right? And remember the digital part of it, or the digital solutions or digital engineering solutions that are on here, it impacts every single thing on here. So BIM, for example, if you have a intelligent model, let's say digital replica of your asset, it then can be linked into a cloud for real-time collaboration. You can then go the wireless route of adding sensors, augmented reality for further development and review. You've got autonomous construction. I gave you an example of uploading a model into like a grader or a machine plant that is intelligent with machine control, and it creates the road for you. Also other robotics that could be involved. Big data, I mean, data would be linked to, again, to everything here. 3D printing or prefab, or we call it Lego construction, those two very big parts, part of the convergence workflow. And of course, advanced building materials with, yeah, if you haven't checked it, go read a few papers. I mean, it's really, really interesting. It's very exciting as well. Okay, so that's where we are. Now, the road to BIM can be daunting. Like I said, there's a lot of different consultants that have started. Majority haven't, even though they know it will be fantastic for their position as a consultant. And just to give you like a quick rundown of what the road of BIM looks like, very summarized. Of course, I already touched on the technology. You're going to need intelligent tools to do intelligent processes. There's no doubt about it. So if you're still sketching things, or I've seen this on certain mining sites where they're still using like color pencils and stuff to mark things off on a hard copy, and that shocked me, right? So technology is a big part of it. Okay. Now, of course, you're going to need the people as well. So you need the people to run the technology. The collaboration is a big part of it. When you've got the people and the technology, of course, you need the processes, you need the standards that come into fruition for this. So they work hand in hand. And when you get all of these ticked and you get a very smooth transition around it, I mean, information capture or data capture is a big part of it. How you would interlink that with your people, your processes, your technologies, your standards. And then, of course, when you get that, the asset can then be expanded in terms of use. So expansion of use, or BIM use, a common data environment, all of that prolongs or is a part of promoting the longevity of infrastructure that we design as consultants. And then this BIM model, let's call it a BIM model, or the asset that is produced at the end of or handed over, it forms the foundation of digital transformation and digital twinning. So a lot of you probably have heard of digital twinning. Remember, the model itself is not a digital twin. So if you have a 3D BIM model, you created a 3D model, it has a lot of data attached to it. So if you click on a column, you can see what eye section it is, properties, whatever it may be. That's great. That's the starting or foundation, the first block that you need for a digital twin, or the recommended for a digital twin. Some people, they just use sensors on an existing asset and they link it to a dashboard with all of those infographics and stuff. That could work. But if you have a digital replica where you have, for example, like a model you're seeing on your screen, how cool would it be? It will be like Iron Man vibes, right? So you would have the 3D model on there and you could go and click on it. You could check the live flow. We've seen this like on factory projects where if you click on the pipe, you got the digital model on your screen. You could monitor the flow, the temperature of the pipe, and depending on how you set it up, you can even flag it for maintenance like 3 months ahead. So you need to replace this pipe. So you know you could plan, you could schedule plant shutdowns, schedule them more effectively, and so on. And of course, this all leads towards a digital twin. So if you get all of the bases right, the groundworks right for the BIM methodology, you can then take the digital replica, creates a virtual representation that is living and breathing, basically. So you could see something live. So for example, on the road, if you have that linked up correctly with all of your sensors, dashboards, your cameras, your digital model, you can then go and derive data, for example, of traffic. Take that data, it'll help you inform the expansion of that road as well as roads around that, also master planning and so on. And then, of course, you can link it to, for example, the pavements. I know there's some POCs or proof of concepts that are currently running that are testing this, where you could monitor the material properties for enhanced maintenance. Buildings, I think they've adopted it the most effectively. So all of the, on the architectural built environment, plant environment, I think is the number one. So from digital processes, prototyping, that's where it kind of started the concept. And you could take that to digital twinning. And at the end of the day, this is where we are going. This is the McLeamy curve. If you use intelligent processes, technologies, integrations, you have transparent workflows that are sustainable, economical. You can troubleshoot things way before construction. You can inform maintenance way before the actual end of the life cycle. It's all an evolution towards a new design process. So the McLeamy curve, just quickly, then I will wrap up. This is where you want to be. This olive color or green color that you have, this is where you want to be as a consultant, where the preferred design process, you do all of the troubleshooting, all of the analysis, all the feasibility here. So the peak of your pressure is currently in your pre and design development or schematic prelim phase. You want to lock everything down here so that when construction comes, you just got a few tweaks. You change, literally, I've been in situations where I've just changed the tender drawing title block to say tender drawings, delete that, put in construction drawings, because everything was on point. You can get to that level. So you don't really need to change anything. So this workflow or process allows you to more flexibility from a cost, troubleshooting, feasibility, planning, optioneering process at this juncture of the project, because you don't want to be making critical decision when you're in construction. I think we all can agree with that, because your ability to impact time and cost, these two governing, is really, really tight. Because if you've gone out to tender, you appointed the contractor, your contingencies are so much, your PI is so much, you don't want to be playing in this part of the graph of the project. You want to kick everything on here so that everything else transitions smoothly right up to operation and handover. So this is where we need to be as consulting engineers. So based on what I've told you, how can I help you? I can't just leave you in the lurch, right? So how can we help you as Baker Bates or as a BIM technical specialist? This is what we literally believe in digital transformation. We help consultants through digital transformation so you can design and make a better world. And the two main things as a technical specialist, this is how I see we can help you as a consultant, or how you can even help yourself. Education, like webinars like this, knowing what BIM is, hearing about it, hearing about industry trends, it's a big part. Also, from a training and upskilling perspective, from beginner to advanced, can help you with that. So for example, if you're a fresh grad, even if you're a senior seasoned engineer and technology is a bit, I can understand, it's a bit radical to understand for you, right? But you have all of this practical wealth of experience, and then you got the graduate that has the technological savviness, but practicality not so much. You're just starting off. So we can help you with understanding the tools, using it in your different industries. We currently got 3 CPD accredited courses that can be done in class or virtually, online as well. So if you are a very busy person, or if you are an RE on the site and you want to catch up on consulting work, or you just capacity wise, it's a bit of a nightmare for you. We've got something called CAD learning, so you can learn on the go. It's available 24/7, and it helps you to design or understand the, put it into practice practically in a technological arena. And then, of course, if you are on your BIM journey already, if you already played around with the technology, at least the technology, and you have some advanced stuff that you want to go over, we can customize that for you, right? And then, of course, if you are a company owner, you're a director, you organization head, whatever it may be, and you want to make or streamline things in your organization, the BPA is the way to go, right? So you look at your people, your skills, what technologies you're using, what workflows you're looking at. And as technical specialists that have worked in the industry and have the BIM accreditations behind them, we can look at them for you, make it recommendations, like in the case of, for example, Junkun that I showed you earlier. That's how it all started. So we looked at them, we optimized the processes, their people, their technologies, their common data environments, and I think they're winning. They're really winning now. So it could be from a technology standpoint, it could be from a project standpoint, or if you might have a daunting project and you probably want it and you're thinking about how much of contingencies I got. I've heard this before in the industry. And you want to find a better way to do things. Pilot projects are the perfect way to start off. So this is from our recommendation how we could help you. But of course, we are open up to like a coffee chat or something like that. And I think that is it for me. So I'm going to open it up to questions. Of course, if you want to reach out to us, info@bakerbains.com, or if you want to reach out to me directly, Shoaib at Baker Bains. I think the S is missing there. Or you can also hit me up on LinkedIn. I think I know most of you from LinkedIn based on the actual people that I've seen logged in. So what I'm going to do is I'm going to look at the chat. So you might see me looking at my other screen and we can take some questions. Okay, so there's one, this always pops up. Is there like a recording or sharing of this? Yes, we'll make this available. The session is recorded. So I would probably post it on LinkedIn and a lot of other social medias. We as Baker Bands will post it. CISA would probably post it. So it'll be widely available. So you can always share this with someone that unfortunately couldn't make it today. So that's not a problem. All right, so I've got a question here from David. Could BIM be used to develop operating models for infrastructure over its life, at least for 20 years? Can BIM be the basis for an infrastructure asset register, linking, conditional? Yes, it can. So that's where you would take the step to a digital twin. So you will have the digital replica, right? Of course, all of that, whether it's, if you're looking at, let's say, a site, a proper site of different infrastructure components, all of that has a design life attached to it. You have a road, design life, depending on the material, traffic loading, it's got that. Structures you might have for deformation analysis, those type of things. Plant, it's the same story. Electric circuits, schematics, diagrams, all of that. Everything you would have a design life attached to it, right? When you have that in a virtual or a digital replica, meaning you have a 3D model on your computer, just simplifying it, with all of that material properties, rebar properties, whatever it may be on there, you take that and then you need to chat to probably an IoT provider. Though they come in and they would then set up or recommend the type of sensors, the dashboards, the back end that needs to be set up so that you could then look at your infrastructure, have maybe a data analysis or data scientists that's good with interpreting data, and they can make recommendation to say, okay, based on the operations on months, March, October, whatever, this was the peak, this was this is what we can do to contribute to the infrastructure longevity and so on. So you definitely can do that. Okay. All right, so I've got another one here. How can BIM be incorporated into operational infrastructure in a water network? I think that ties in with David's question that I've just answered. So irrespective of what infrastructure you have, if you really want to monitor it properly, like in a live environment, you're going to need an intelligent 3D model with metadata, and then you're going to need IoT integration, Industry 4.0 dashboards, and so on to monitor it. I think that was from Mashhood, right? Thank you. Okay, this one I get quite a bit on different panels. What would be the most commonly used software for BIM? Does it differ for different sectors, or do you predominantly use Revit for various sectors? It's not that straightforward. Of course, you do have different developers globally. Of course, we back Autodesk here as Baker Paint. there's different developers, and then of course there's different solutions used per segment or specialization. So if I'm talking from an Autodesk perspective, if you're doing infrastructure or civil infrastructure design or horizontal construction, then of course you've got Civil 3D, you've got InfraWorks. If you're going on the built, structural, mechanical, electrical, plumbing, then you've got Revit, you've got robot structures, you've got advanced steel. And then, of course, if you're more on the mechanical process plant side, you've got Plant 3D, Inventor, Fusion, and so on. So that's talking products. However, my recommendation would be you need to identify the challenges first before you even think of a tool. And again, we also will help you with that. So um, it's not more the technology, it's first looking at the problems you need to solve, the challenges that you have, and then we could look at it as technical specialists and recommend a process, a procedure, a workflow, and so on. Okay. All right, I've got one here from, okay, this question box is just increasing now, but it's cool. It's cool, we've got some time. Uh, this is from Vauda. What tools or software packages do you recommend we become proficient in so that we may use BIM technology properly? Like I said, there are different vendors or technology developers throughout the world. You need to look at the challenges or the type of things that you would encounter in your project or in your professional sphere. Look at that, then you would probably have to do some research as to which will be more viable in terms of scalability in your organization. And then also check if with that developer, if you can, of course, if it's Autodesk, you can reach out to me directly or to us, Baker Benz. There's the contacts there. We can help you have a chat and we can advise you, okay, this is BIM compliant. It has the open BIM standard. It can export to this. If it's not Autodesk, then you have to check with them. And I would say as a professional, do a bit of homework, right? Google, keep up with different industries, different professional bodies globally. I think ICE, Institute of Civil Engineers globally, a good one. NBS is good uh, if that's just in the civil space, but there's a lot. So if you keep up or follow with professional bodies, you'll see these articles pop up that you can have a read of. I publish a few every now and then when I get some time, but there's a lot readily available online. I mean, scholarly articles, if you want legit stuff, or if you just want quick informatory articles, you pop it in Google, you will find really good information on BIM. Most of them are done globally, but now we've seen a lot of South African or African-based research and articles that have been generated, which is quite positive. Okay, Tumeleng, since BIM can produce a 3D model prior to construction, can incorporate all the scope of works for a complex project. That will be governed by your project charter. We call it a project charter or BIM execution plan. So you would need to have an inception meeting and you would need a technology consultant or provider like ourselves, preferably, or a BIM champion to partner or lead that for you, because then you know the roles, the responsibility, what's everyone's output. We can then, from an engineering as well as a digital solutions perspective, put a plan together for you and then everyone abides to that. So you can do that. You can then attach all of that data to a common data environment, so it's readily available to the custodian of that data. I mean, I can talk a lot about it, but in short, yes, you can, but you need a plan, you need a BIM champion, or you need a digital solution expert to lead that with your consultants or consortium. Okay, I see a few questions here coming like specifically on the technology, like Revit's coming up, Civil 3 is coming up. Look, it's great that you have made that transition into like the intelligent BIM technologies that are very popular globally, right? That's a fact. So Revit is one of them, Civil 3D is one of them, AutoCAD is still around, Inventor is there. We call them hero products in the Autodesk world. But like in terms of the next step, that really comes down to your environment. So meaning first become proficient in the software, more importantly in the engineering. So yes, you can be a great modeler, a great designer, you could be quite savvy with the product, but if your designs are not practical, That's a concern. So I would say partner if you're new or you're fresh into the engineering or consulting environment, you need to be at the hip with someone that's quite senior. Sometimes it's quite challenging, I agree, because either they're on site or they're attending meetings or whatever, but always try and get someone's input to make you understand what you're designing first. The tools help you to an extent. I'm not going to lie, they've got checks and stuff in the tools so that it makes you a much more it like mentors you to an extent, the tools to design much more effectively. Depending on which specialization you are, that, nah, this didn't work last time. I know I checked it, whatever. But I would say get comfortable with the tools, get more comfortable with your theory that you did on campus or studies. And then from there, try and get into more complex projects. And then from there, if you want to be, there are user exams that you can take. There's different steps that you can take in the BIM sphere. But if you want to know more about that specifically to your environment or to your company, to your organization, drop me an email. We can set up a chat sometime. Okay, there's one from David. How was the BIM mandated for public infrastructure standard implemented in other countries? So that was an agglomeration between the actual government themselves or the region, like our municipalities or provincial levels. So some of them started at the city level, not if I talk in our context. So you'll have municipal, you have provincial, then you have those different levels. It started at the smallest levels. It then got documented into a standard. It then got approved by an ISO agency, of course. That agency then they applied it in different projects. Then they fostered the stats or the data. You need data to comprehend or to compel mandation because you need to say why it should be mandated. And then, of course, you need public participation to come on. They review it, they sit on a committee, they look at the legislation or the law behind it, all the documentation, and then they approve it. So a big part of getting it mandated on a municipal or government level is we need public participation or public buy-in, right? I know some projects in the private sector that they've mandated it, or different companies have already mandated it on their projects. So if you're working for them, you have to be BIM compliant, we call it, or you must be BIM savvy so that you give them the certain outputs. So that's on a private sector type of thing. And like I said, we've also having it on our consultancy in South Africa who have taken the initiative and already started implementing it in projects. Also increasing their ecosystem and so on. So there's projects that will allow you, or consultants or principals of the project that will allow you to come on, provided that you conform to their way of working, that being BIM way, common data environment. We've seen it, we've been a part of projects of this nature at Baker Bains. So definitely you need public buy-in, but again, doesn't stop you as a consultant, as a professional, of starting to champion it already, because um, you rather be ready than get ready, because it's gonna happen. It's gonna happen where you're gonna need, all of a sudden, maybe it'll be mandated. I can't give you the timeline on it. It could be next year, it could be this year. I mean, we don't know. But you can see the probability of it. If you deal with stats, the probability of it is quite likely it's gonna happen soon. So as a consultant, I always advise the users start with it now, be comfortable with it, because when it comes in full swing as a mandation, it's mandatory, then you don't want to be on the bandwagon of playing catch up. So be ready rather than get ready. Okay, I'm just going to take one scroll to see if I missed any questions. Okay, I think that is it. I don't see any questions on here. So thank you, everyone. I'm going to hand over back to Mohammed just to close. But thank you all for the opportunity. I hope it made a lot of sense. It gave you an idea what it is. And yeah, thank you, Mohammed and Caesar, for the opportunity. So over back to you.
Thanks, Shuaib. I think the most important aspect for the success of BIM in the construction industry is adoption by everyone involved in the life cycle of the project. And in order to achieve this, we do need to promote and help everyone understand what BIM is and the benefits of utilizing BIM. I would like to thank Shuaib and Baker Baines for accepting our invitation to present at this event. It was a really informative session, and hopefully we have more of these in the future. I would also like to thank all of our CISA YPF committee members for making this event happen. And lastly, I would like to mention our next event, which is planned for the 2nd of June 2023, which will be a soccer tournament at the soccer courts at Konubia Mall. The invite to this event will be shared with all. Thanks to everyone for attending this event, and enjoy the rest of your day. Thanks.